Hello everyone. Today we're going to talk about analyzing the first derivative graph. These are extremely common questions on the AP exam and oftentimes will be asked a couple times in multiple choice and in the short answer. Okay, this first graphic organizer is a great way to kind of put together everything that we've talked about over the past several weeks, and we're going to use this and the conclusions from this several times as we go through today's notes. So just a reminder here, if you are looking for the extrema, you should be going to the first derivative. You're looking for when the first derivative is equal to 0 or undefined. It will have a relative max if f prime changes from positive to negative. It will have a relative min if f prime changes from negative to positive. Concavity is the second derivative. Concave up when the second derivative is positive, concave down when the second derivative is negative. Points of inflection are also from the second derivative, and that's when the second derivative is equal to 0 or undefined and the sign changes. Okay, so this first example says the figure below shows the graph of f prime, the derivative of the function of f on the closed interval -8 less than or equal to x less than or equal to 7. The graph of f prime has a horizontal tangent line at x equals -3 and x equals 4. The function is twice differentiable with f of 0 equals 5. Okay, so they're giving us a lot of information. We kind of want to break it down. We have a closed interval, so that means we're stopping between -8 and +7. Okay, horizontal tangent lines. Remember, that means that the slope is 0 here and here. Okay, that should be a little bit lower. So that means the slope is 0 at those two places. All right. So the first thing that we want to do, I always want to make sure that I know I am looking at the first derivative graph. So I'm going to make a big f prime right next to it. All right, and then we want to go ahead, and if we are using this graph to analyze our information, I'm going to make a sign chart kind of going the other way. Remembering that I am given the graph of f prime, how can I make a sign chart for f prime? Well, okay, I'm going to first of all start off by having my closed interval of -8 to 7. Okay, now this is the graph of the derivative. So as we fill in the information, we're filling in when it's positive, negative, and 0 from the graph. All right, so first of all, where is it equal to 0? Well, when is f prime, when is this graph equal to 0? Well, I would say it's equal to 0 when it crosses through the x-axis. So that would be at -7, at 0, and at +6. Those are the places where it's equal to 0. So f prime equals 0 there. Okay, now to simply fill in the positives and negatives, which we normally have on our sign chart on the top, okay, we get those from the graph. So look at each interval that you have between -8 and 7 on the graph. Where is the graph? Is the graph positive or negative? I would say because it's below the x-axis, we would definitely say that that is negative, meaning that the graph of f would be decreasing there. Okay, between -7 and 0 in this interval, what's happening with the graph? Well, the graph is now above the x-axis, and so is positive there, increasing. All right, between 0 and 6, I would say that the graph is below the x-axis, so negative, so the original function would have been decreasing. And between 6 and 7, it's above, so it's positive, the original function would be increasing. Okay, so this gives us a lot of information about the original given the graph of the derivative. The second thing that I should be able to create is a graph of, or a sign chart of f double prime. Okay, so remember the sign chart for f double prime is going to communicate to us about concavity, and from that we're going to be able to learn about inflection points. So how can I get information about f double prime? Well, remember, we are given the graph of f prime. And so if I take the derivative of f prime, I then have the information about the second derivative. Okay, well, if I'm taking the derivative, what is another word for derivative? Slope. So I'm looking at the slopes of the graph of f prime, and that's going to tell me about f double prime. So the first thing I want to look for are any time when the slopes are 0 or undefined. Remember, when we want to find the critical values for f double prime, we take the derivative of f prime, and then we set those equal to 0 or find out when they're undefined. So looking at my graph, I should look for when the slopes are 0 or undefined. Okay, we already were given here and here that the slopes were 0. So at those x values, I'd say that's at -3 and at +4. So I'm going to try and put those in, line them up with my first chart. Okay, and those were both slopes of 0. There are no places on this graph where the slopes are undefined. Remember, slopes would be undefined if they came to a corner, if you have a vertical tangent, things like that. All right, so now I'm going to go through and I'm going to fill in my slopes. And remember, all I'm doing is deciding if it's positive or negative. So if I look here, going up through the interval from -8 to 3, what would we say about the slopes from -8 to 3? Well, I would say that that graph is increasing, and therefore the slopes would be positive. So if my second derivative is positive in that interval, I would say I'm concave up there. All right, from -3 to 4, okay, what's happening there? Well, I would say my graph is going down. I would say my slopes are negative. So I'm going to go ahead and fill in a negative, concave down. From 4 to 7, again, my graph is going up. And so, again, I would have a positive slope and concave up. Okay, so now that I have both of those sign charts, I should be able to answer a whole load of questions that the AP could throw at me. Okay, so the first question says, find the x-coordinate of each local minimum of the graph of f. Justify your answer. All right, so if I'm talking about minimums, I remember that was the first derivative. And what am I looking for? First derivative to change from negative to positive. Okay, so if I look here, and if I just follow my arrows from my from my first derivative, you can see I decrease to a minimum, increase, and then decrease again to a minimum. All right, so I would say that at x equals +7 and at x equals +6, I would be at a local minimum. And the reason why, see this justify your answer, is because f prime changes from negative to positive. All right, next question. Find the x-coordinate of each of the points of inflection of the graph of f. All right, points of inflection tell me I need the second derivative. Okay, and this time I need them to just change sign either way. So anytime you change sign, you are going to, for the second derivative, you're going to find a point of inflection. So if I look here, I would say that I have a point of inflection at x equals -3, looking at this chart here, at x equals -3 because I'm changing from positive to negative, and then I change from negative to positive, so at x equals 4. So those are my 2 points, my 2 x-coordinates of the points of inflection. So x equals -3 and x equals 4. And my reasoning would be that f double prime changes sign. Okay, the third question says find all intervals on which the graph is concave up and also has a negative slope. Explain your reasoning. So this is why I kind of tried to put my sign charts one on top of the other, stack them on top of each other and line the numbers up, because it says when is it concave up and also a negative slope, and I'm finding intervals. So concave up, all right, I'm just going to go ahead and circle that. Where would I be concave up? Well, that was here, and that was also here. But it has to have a negative slope. So negative slope would be talking about the first derivative. So this was talking about the second derivative being positive, and negative slope is talking about the first derivative being negative. Okay, so that would be here and here. So you basically are finding when do those overlap. And so I would say that those overlap between, let's see here, -8 and -7. And then again between 0, nope, just kidding, between 4 and 6. So between -8 and -7, and between 4 and 6. So to explain my reasoning, I'm just going to say exactly what I already thought through, that in order to be concave up, it was that the second derivative was greater than 0, and that the first derivative was less than 0. Okay, so the last question is asking us to sketch a possible graph of f on the axis provided below. So first thing I want you to want to stress is that it's a possible graph. There are many, many, many different ways that I could draw this. Okay, so I'm just drawing a possibility for what the graph could look like based upon my sign charts that I have here. So I copied them and brought them back down because we're going to use these. Okay, the other piece of information that we need is this this value that they gave us in the very beginning of the problem. They told us f of 0 was 5. That's an initial condition, and it gives us a value on the f graph. So basically it's giving us a point. The 0, 5 is on the graph. So I'm going to plot that point. All right, so now I'm going to just go ahead and follow the information that I have from my sign charts. Okay, remember f prime is giving us information about when the graph of f is increasing and decreasing, and f double prime gives us information about when it's concave up and concave down. So I'm going to first focus on the f prime, all right, and when it's increasing and decreasing. Remember, these are my x values down here. Okay, not my y's. I don't know my y values at all. The only y value I do know is 0, 5. All right, so the first thing I know is that, and again, this is a closed interval, so I'm starting at when x is -8. Okay, and I know that I need to be decreasing until I get to a local min. This was a min at x equals 7. Then I'm going to increase until I get to a local max at x equals 0. And that, like I said, is the only point I know. So I know that that 0.05 is a local max. Then I'm going to decrease again to a min. Okay, and then I'm going to increase until I get to the end of my graph, which is x equals 7. So just kind of sketch in what a possibility for that is. So we're going to start at when x is -8. All right, we can start anywhere, any y value we want. So say I start down here. Okay, I'm going to decrease to a local min at -7. Then I'm going to increase between -7 and 0. Now I know the point at 0 is 5, so I have to increase all the way up to here. Okay, then I'm going to decrease until I get to a local min again when x is 6. And then I'm going to increase until x is 7. All right, so now all I want to do is check my concavity. I just want to make sure that I really am concave up where it says and concave down where it says. So it says I should be concave up between -8 and 3. So between when x is -8 and when x is 3, I should be concave up. So in fact, I would agree that I am concave up there. At x equals 3, or x equals -3, I should be changing from concave up to concave down. And I would again say that yes, that is what's happening. Then from -3 to 4, okay, when x is 4 is where I should have my next change. So here I can say again that yes, between -3 and 4 I'm concave down, and then after I am concave up. So I might need to go back and tweak that, but the way that I happened to graph it, it was perfect, okay? So as long as you are following these two sign charts, your sketch is going to be acceptable. Okay, the second example we have here, again, they're telling us that this is the graph of G prime. So again, I'm going to write that G prime right next to it. So I remind myself that I'm looking at the graph of the derivative of G. Okay, and so the first thing we want to do in order to answer these questions below is we want to make sure that we make our sign chart for G prime first and then one for G double prime. All right, so I'm going to go ahead and set up my number line. It's from -8 to 8. I'll label the top G prime and the bottom G. First thing, where are my zeros? Where does G prime equal 0? Well, I can see here that it equals 0 at -8, at -4, at 0, and at +8. So I'm going to put those values on my number line. And I'm going to mark them with zeros. 0 and the 8. All right, the next thing I want to do is say where is G prime positive and where is G prime negative. Okay, so because remember where G prime is positive, that is where the function is increasing. And I can see here that the interval between -8 and -4, okay, what's happening here? The graph is above the x-axis, so positive. All right, the next interval is between -4 and 0, and there the graph is below the x-axis, so negative, and that means the original function would have been decreasing there. Between 0 and 8, it's above the x-axis, so increasing. Okay, once I have that, I'm ready to work on my second derivative number line. So again, bounded by -8 and 8, label with G double prime and G. Okay, this time, remember, this is the second derivative. These are the slopes of G prime. Okay, it's the derivative of G prime for the second derivative. So I'm talking about when is the slope equal to 0 or undefined. So if I find my critical values, I'm looking for when the slope is equal to 0 or undefined. So let's take a look at our graph of G prime. Where are the slopes either equal to 0 or undefined? Are there any horizontal tangents? So I can see that right here there is a horizontal tangent, and right here there's a horizontal tangent. So I have 2 zeros. So I'm going to go ahead and put those on. All right, I have -2 and I have +4. And those are zeros. Okay, the next question, are there any undefined values? Are there any places where the slope is undefined? Okay, and we would say that at -6, and we'd also say here at 0. Do you see at -6 it comes to a point? So that would be an undefined. And then also at 0. At 0 we have a vertical tangent. So we would say the slope is undefined at 0 as well. Looking at my graph, I have one more place where the slope is undefined, where there is a peak or a kink, and I can see that that happens right here, okay, at -4. Again, I have kind of a kink that occurs in my graph, and I would say that that's another place where the slope is undefined. Okay, so now I'm ready to start looking at the intervals in between these x values for G and determine what's happening with the slopes of the graph of G prime. So if I look at the first interval here, the first interval is between -8 and -6. So on the graph of G prime between -8 and -6, what's the graph doing? And I would say that the graph is going up. It is positive. So there's a positive slope there, and therefore I'm going to put a positive here, and that tells me it's concave up. The graph of G is concave up. All right, in the next interval from -6 to -4, I would say that those slopes are decreasing, okay, and so we are concave down. From -4 to -2, it continues to have negative slopes, continues to be a decreasing graph, so continues to be concave down. Between -2 and 0, we start to go up again, and so we have a positive slopes, and we would say we're concave up. Okay, between 0 and 4. So again, if you look at between 0 and 4, that is still increasing. Those slopes are still positive. If I were to draw slopes on here, anywhere, these are all positives. Okay, so we had positives here, down here between -2 and 0, and then we continue to have positives here. So that continues to be positive, continues to be concave up. Between 4 and 8, though, if I look at this part of the graph, I would say that that is decreasing, and so concave down. Remember that the second derivative is just the slopes of G prime, and so I'm just asking myself, is that graph have a positive slope or a negative slope in that interval? Okay, let's go ahead and answer these questions now. For -8 less than x less than 8, find all values of x at which G has a relative maximum. Okay, relative maximum, remember, we are looking at the first derivative whenever we want relative extrema. Okay, and for a relative maximum, the first derivative has to change from positive to negative. So if I'm looking at my G prime sign chart, where am I changing from positive to negative? And I would say that that occurs from here and here, and so that would be an x value of -4. There is one place where we change from positive to negative. So I would go ahead and say that when x is equal to -4, and my justification would be that g prime changes from positive to negative. Okay, the next question asks us, between -8 and 8, find all values of x at which g has an inflection point. Inflection points ask for the second derivative. Okay, and this time we just needed to change. All right, so now I'm looking at the second derivative, and you can see here that we are not changing for every interval. So where specifically am I changing signs? Well, I would say right here at x equals -6. I would say it happens again at x equals -2. It happens again at x equals 4. And again, you would say their justification would be because the second derivative, oops, it's g double prime, changes sign. All right, last question. Find all intervals on which the graph of g is increasing and concave up. Okay, so the graph of g is increasing. That's our first derivative. And the graph is concave up. That's our second derivative. Okay, so we are looking at places where the first derivative is positive and the second derivative is also positive. Okay, so if we look here, these are the two intervals in which the first derivative is positive, and here are my intervals for when the second derivative is positive. So we want those overlapping times. All right, so I would go ahead and say that that would be between, let's see here, -8 and -6. Then I would say, again, between 0 and 4. So those are the two intervals of time in which what's happening? Our first derivative, so g prime, is greater than 0, and the second derivative is also greater than 0. Okay, for number 3, I'd like you to go ahead. Again, they're giving us the graph of f prime. And so I'm going to make a big f prime next to this, okay? So I remember, even though they tell me here, I want to make it bigger, okay? So I want you to go ahead and make a first and second derivative sign chart for this graph, okay? So I'm going to ask you to pause the video, do that on your own, and then check your work with mine. Okay, so go ahead and check your work with mine. All right, as we take a look at the first derivative sign chart, I've thought that I had my zeros, my critical values, where f prime crosses through the x-axis, happen at -2 and 2. I said that between -3 and -2, the graph was above the x-axis, and so therefore positive. Therefore, f would have been increasing. Between -2 and 2, well, this whole graph between -2 and 2 is below the x-axis, and so negative. And also between 2 and 4, it's also below the x-axis, so then also negative again. So decreasing and decreasing. Okay, sign chart for the second derivative. All right, so my critical values are, of course, where the graph of the f prime is either, the slope is either 0 or undefined. And so my first place where the slope was undefined here, came to a kink here. Okay, so if it comes to a kink, if it comes to a point, if it flattens out, all right, those would be times when the slope would be undefined or 0. So here it came to a kink, so we'd say the slope was undefined at x equals 0. Okay, I also said that at x equals 2, I have a horizontal tangent. It flattens out, and so that would be a slope of 0. Okay, now I'm looking at the slopes between -3 and 0. What's happening? Well, I would say that that is a decreasing slope, so negative. Okay, between 0 and 2, I would say that that is an increasing slope, so positive, concave up, and then again, decreasing, negative, concave down. All right, so I want you to go ahead, pause the video again, and answer questions A and B. Okay, so let's check your work with mine. The first question just said on what interval is, if any, is f increasing. Okay, so I knew f is increasing when they are asking that question. That's talking about the first derivative being positive. So I looked at my first derivative sign chart and I said, when is the first derivative positive? Between -3 and -2. Okay, the second question asked for the points of inflection. Okay, points of inflection I know. I just kind of made a note to myself. I'm looking for the second derivative to change sign. So I'm looking at my second derivative sign chart and it changes sign at x equals 0 and x equals 2. All right, part C is a little bit different. It says find the equation for the line tangent to the graph of f at the point 0, 3. Okay, so remember when we are writing equation of a line tangent to a graph, we need two things. We need the point, which we have, 0, 3. Okay, that gives us our x and our y value for our equation. The next thing we need is we need our slope. Okay, so let's think about it. How am I going to get the slope for the graph of f? Well, isn't the slope for the graph of f prime, the derivative of f? And isn't that the graph we have right here? Okay, so what is our x value that they're asking for? They're asking us to find the slope of f when x equals 0. So if I go to x equals 0 on my f prime graph, okay, when x is 0, what is the slope? What is the point? Okay, on f prime, the point is 0, -2. So that means the slope at 0 is -2. So now I have my point and I have my slope and I'm ready to write the equation for the line tangent to the graph of f at that point. Okay, so I'm going to say y minus 3 equals -2 x. X minus 0 is just x. Okay, ladies and gentlemen, that's all I have for you tonight. I hope that you really are grasping and just wrapping your head around the idea that they're giving you the graph of f prime. And so the graph of f prime communicates to us about the graph of f, but it also communicates to us about the second derivative graph. So it's kind of the perfect middleman to give us information about the original function and to give us information about the second derivative, so again we can get more information about the original graph. All right, so that's why these are really popular questions on the AP exam. We're going to practice some more and some actual AP questions. Actually, this number 3 here was taken from an AP exam. And so A, B, and C, there was a part D that uses something you haven't learned yet. But all of A, B, and C, clearly you could learn from this lesson. All right, so thanks so much, and I will see you next time.